Thank you. So I know it's kind of the last session, and there has been quite a bit of content covered already. So we'll keep it light and simple, and we're going to focus on how to democratize analytics. Basically, every single manager, every single employee, how do they make use of analytics in their day-to-day tasks? That's the kind of the motivation behind this presentation. So I'll start with a very simple story. So an airline advocacy or travelers advocacy group, they came up, they did some big data analytics, they collected a lot of data from flight schedules over the years and hired some data scientists, deployed some high-end technology, and they came up with this conclusion. And they said that, well, every high probability that every 10 millionth flight will have one of the pilots drunk. So that kind of started a scare in the industry because this roughly translates into maybe a flight every 2 years or something like that, and people started canceling. So the airline executives all got worried about it and said, well, we need to do something about this study. And what they did was they sanctioned their own study. They hired some more data scientists, they collected more data, and they said, okay, let's see if we can dispute that. So the airline data scientists, they came back and said, you know what, we've looked at their models, we've looked at their data, and it looks like their conclusion is actually correct. However, we have also found, while working with big data and some analytics technology, that there is hardly any probability that both pilots would be drunk. So here's what we recommend. That you get one of your pilots always be drunk. Now, what's the moral of the story here? Do you think the traveler advisory consumer advocacy group, did they have poor technology? Did they have poor quality data scientists? Did they not use the best algorithms? Or do you think the airline data scientists messed up with the data quality or with the Hadoop cluster or whatever? It's none of that. Both technologies, both human skill were probably fine. But the essence of analytics and its application in business, in operation, is what you do with it. So data scientists are great at figuring things out in data, but what you do with it should be taken out of their hands. And should be put into the hands of the people who actually run the business. So with that, we're going to first jump into defining analytics. And I have been working with analytics for a good 10 years now. My prior 10 years were working with data and data warehousing and very early days of data integration and ETL and all of that. And then I started working with actuaries and brokers. So a lot of people who use statistics and mathematics, fraud detection, anti-money laundering, that type of stuff. And I really saw firsthand what they did with the data. So my perspective of analytics is very different from what the current definition is turning out to be, where it's kind of anybody who can do search and query these days, oh, we're doing analytics. Well, no, there was always a well-defined definition to what analytics meant, how it was done, how it was carried out, what techniques were used. And data warehousing was also very well defined. So what I'm going to do is I'm going to start to, first let's set the ground rules right, because the analytics that we're going to be talking about and its power to an organization, we need to first define it. Your operational systems these days, any ERP systems that you buy or any operational systems that you build, have a lot of the data analysis capability built in, some very basic ones that you need for your day-to-day operations, your users. They have screens, they have search screens, query screens, they can do some basic reporting right there in the operational system. And typically they are looking for stuff in the now, present. There's somebody on the call, they want to look up their profile and kind of take some actions, some outstanding dues that they need to follow up. So in the present box, you have your operational systems and some basic capability to look at data and do something with it right there. And then there is the data warehousing box. So the historic or the past is where you kind of start to look at some summary reporting, some historic trending reporting. You start to develop some metric and KPIs. And then, of course, also some analytical applications, GIS, visualization, all of that. In that box, what you're really doing is you're looking at historical data that has been collected over time from the box below, and you're making use of that to try and figure out, okay, what really happened. So the bottom box is telling you what is happening now, and the box above it is telling you how we did, or what just happened, or what has been happening. The box underneath is operational, that's ERPs, your operation systems. The box above is your data warehousing, very well established, has been there for a good 15, 18 years, good stable technology, a lot of skill set, manpower, ETL, OLAP, all of that good stuff. Analytics is where it kind of, okay, now that we have looked at what has been going on in the past, we're going to try and recommend something. We're going to look at, okay, what should we do? And that's the differentiator between analytics and reporting and BI dashboarding. But that's where the line is. And that's where you get predictive models, descriptive models. They could be AI driven, coming from machine learning and data mining and from the computer science background. Or they could be coming from statistics, regression and stochastic analysis, operations research. They try to solve the same problem using different methods. And interestingly, the trend you will see is that on the East Coast, New York, Wall Street, financial sector, everyone is heavily into statistics and mathematics. They're using those techniques to figure these things out. What should we be doing? Stock to sell, stock to buy, trade a commodity, not to trade a commodity, risk going up, risk going down. On the West Coast, companies like Facebook and LinkedIn and Google, day one, they realized that they need analytics for everyone. Everyone in their organization needed to make use of analytics. There was no way they could rely on data scientists, which are hard to come by, hard to train. So they totally relied on data mining from the get-go. And this is a clear contrast. We don't know which one's better. There are some academic debates going on as whether the statistics way to analytics is better versus the data mining way. There is merit to both. So within the what you should do about it, there's two aspects. There's the analytics model, which what we looked at. So the airline industry came up with their model, and the consumer advocacy group, they came up with their model. But then there's also the decision strategy, the most important element. Okay, what do we do with this thing now? That we have a prediction, we have probability that this will happen. What does that really mean? How should I use that information in my business? Any questions here? We clear on the ground rules? So this is what analytics is. We're not talking about dashboarding and BI and all of that. Okay. So here's a simple example. Those of you who may not be familiar with the predictive analytics, I'm just using a very simple example to kind of illustrate how this thing works. So here's some data. There's like millions and millions of rows of sales history that I have here. And what I have here is, let's see if we can get to work. Okay, so you've got age, income, student, and the credit rating. So these are your input variables. And then this is your, what we call the predictive variable. And this is from your historical data. So you know that age was less than 30, income grade was high, and he was not a student, and fair credit rating, it did not buy the computer. So you pull this kind of information from your sales transaction system, and you kind of designate whether they bought or they didn't buy as a predictive variable. Then what you do is you submit this data to any data mining tool, and what you see here is what we call a decision tree. That's one of the data mining techniques. There are lots of software out there that you can use. They are very graphically driven, so it's very easy to put them to work. A trained data analyst who understands data, understands querying, takes maybe 2 days or 3 days to get it to work, and that's all. And what it does is that it kind of looks at the input variables and tries to figure out which input variable is most heavily influencing the buy yes versus the buy no decision, and it comes up with something like this. So you pass training historical data, and the tool, the data mining tool, comes up with this as an output, and this is what we call a trained model. So this basically means that if you have a new customer now coming in, you can run their record through this tree and see where they fall. So if somebody who is 45 years old with a poor credit rating, where do you think, with a fair credit rating, where do you think they're going to go? They're going to fall, so their age is 45, so they kind of go into this branch. Each record is passing through this branch. They looked at the credit rating, say it's fair, so you have a prediction, okay, they will buy. So maybe you want to focus your energies there, maybe your salesperson should work with them, and wherever the prediction says that they're not going to buy, you may not want to spend time over there. So this is a very simplistic view of how you train a model and how you use a model. Here is a little more kind of detailed example of that in a different graphical structure. So here's your training data, and you have your predictive variable, and then you pass it through a decision tree algorithm, and these algorithms, as I said, are available in open source or in a lot of database engines. And these algorithms, when you run the data through it, they create a model. And the example of that, or another analogy to explain, is that the algorithms are a general purpose musical instrument. Yes, there are good expensive ones, and there are ordinary ones, but they are all music instruments. What you do with them depends on the data that is passed through. So the same algorithm will give you a predictive model depending on the quality of data you pass through it. If your data has good spreads, has good depth of history, then you will get a good model out of it. If you're going to pass 10 rows through it and try to figure out what's going to happen, it's probably not going to give you anything. So the algorithms are general purpose. And you can take the same algorithm, apply it to a problem in manufacturing, apply it to a problem in healthcare, apply it to a problem in finance. It's agnostic. The data that you pass through it, that's what's critical. So you get your model, and then new data comes in. So this is kind of your sales lead data coming in. So you've got like 3 of these customers coming in, and you really don't know if they're going to buy or not, but you want to spend the time with the ones who have the higher probability of a purchase. So you have this data coming in with the predictive variable as empty. You pass it through the model, and the model sends back an output whether they're going to buy or not. So if this is the simplistic definition of analytics, then the next part of my kind of discussion here is how do you make sure that this is available to everyone in the organization? So let's try to look into that, because pretty much every decision that an organization is making, you can complement that decision with some predictive information coming in. Every operations manager has a handful of resources. There's just enough hours in a day. You want to maximize the deployment of those resources towards the high-yielding transactions or high-yielding decisions. In the present state, the limited use of analytics, what's happening is that if this is your org chart and you're a mid to large corporation, maybe $200 million plus in revenue, then you may have some customer analytics going on in your marketing department. They may have a couple of guys there who know what this thing is. They may have a tool that they may have built or purchased, or they may have a consulting firm working with them. And then also, maybe in your finance department, somebody looks into these things and they have some capability. So the use of analytics is kind of spread out. It's far and wide. The organization as a whole is not leveraging this technology as much as they can. And typically what happens is that you have a data scientist in their kind of silo, and you've got all these operation systems running, and the data scientist kind of is responsible for pulling all that data into his own little world, and then and they create a small database there. They are responsible for bringing the data in, the cleansing, and almost 60–80% of their time actually goes into some of those rudimentary tasks. And then they kind of build some statistical models on it, and based on those models, they have to go back to the business and kind of convince that, okay, this model now works, anything coming out of here, we can take a decision on it and convert that into more of a policy decision. And that's how you get some business benefit out of it. So you need a problem statement so that the data scientists can actually go and find the relevant data for that problem statement. They're not going to be able to, if they are working within the finance risk area, then within a corporate CFO's office, then they will be limited to the data around that space. They will not be able to aggregate all the data from all the various systems that could be relevant, but they will not have the capability to go do that. So the problem statement will dictate the type of data they're going to use in their analysis. Then, of course, there are business processes, so every piece of data has a context to it. They need to understand that, how and when it's created, how to link the two together, how to add them up, stuff like that. And then, of course, they have to deal with the various operational systems, bring data out, the data integration, model testing, model rollout, and then overall prove the worth of their entire effort. So this is actually how it works today. And that is why you see that a single individual or a small group of people are under tremendous pressure because they have to do all of this to get results. So what I did was I spent some time on DICE and Monster job boards, and I started looking at data scientists, what people are looking in terms of a job description. So if someone was hiring a data scientist, what kind of skills they were looking for. And this is kind of a summary of that. So you at least have to have a graduate level education in some data sciences, statistics, AI, mathematics, whatever. And you should have some experience building models. You should know a problem area pretty well so that you understand the data, the context, the problem statement. Database knowledge, of course, is an absolute requirement. Knowledge of some of these tools. Advanced SQL knowledge to handle complex queries. Of course, presentation and documentation skills. You gotta be able to explain this to everyone, what you're doing and how you're doing it. Ability to build a business case, to go back to the business and tell them that, hey, we found something very interesting. Here's, you spend some more money, open up a shop here. It's gonna help you with more customer retention. Whatever is the overall strategy that they come up with. Project management, of course, and excellent communication skills, because they cannot really talk mathematics or statistics with the business side because they're not going to understand. Now, you see a pattern here. I mean, this list, I mean, where do you find these people? I mean, it's not easy to get a hold of these people. And increasingly, I see in these job ads that, oh, knowledge of Hadoop and some Java so they can program these things, and all of this is required. Well, if you find these people, you might as well send them over to Rome and ask them to redo the Sistine Chapel. They'll do a better job of what Michelangelo did. So this is just unrealistic, right? And here's another view of that. So you first 20 years are gone into that, then another 5 there, another 10 there, another 15 there. So you will become a data scientist when you're ready to retire. No exaggeration. So that is the current model that the industry is kind of going towards. What they're trying to do is, well, we need to do better. We need to have better education. We need to train these guys. And this McKinsey study came out in 2011 that said that we're going to be short by 200,000 data scientists. Where are you going to get these data scientists? And even if you get them, you're not going to be able to retain them. They're going to be very expensive. And apart from a couple of departments within an organization that have good budgets, maybe the profit centers, they may be able to afford them, but your purchasing, your HR, your facilities management, those groups, those cost centers will never have the funding to hire this type of skill set and retain them over a longer period of time. So then how do you adopt? So we do recognize that the value of analytics, it can be applied to every single business decision that is being made in the organization. But to get to that, there is this huge hurdle, bottleneck of manpower. So there's two things here, and I think the industry is confused between these two, and I would strongly recommend that December's Harvard Business Review had 2 articles in there. One by Tom Davenport, who has been kind of the leading voice on the analytics side and its adoption. And then the other article is from a couple of professors from MIT and UT Austin. And what they are in that arguing exactly what this shows you, discovery analytics versus decision analytics. So discovery analytics is a kind of a top-down situation where you bring all your organization's data under a major CEO-driven initiative as a master program, chief data scientist and chief data officer, lot of money, lot of budget, and they are looking at the organization holistically and trying to figure out what should be our strategic step, what's next for us. Discovery analytics is open-ended. You really don't know what you're looking for. You're looking for some competitive edge or efficiencies over a longer term, 10, 15, 20 years. And you're looking at your data to find that insight so you can leverage that and take the company to the next, in the next decade. Large capital investment, but the Harvard Business Review article that I'm talking about argues against this by the last bullet here, easy to replicate results. So they're talking about a bank that deployed a big data analytics team, hired top consultants, brought in huge technology. They were looking to optimize their ATM replenishment, cash replenishment, as well as ATM maintenance and ATM location, where to deploy more ATMs. So overall, the ATM operations team needed some insight from data scientists, and they did that. They figured it out. The bank got a lot of valuable insight from it. Based on that, they came up with a strategy. Before they could put the strategy to work, that knowledge through those consultants and a couple of employees was already out there. The competition knew about it already. So you spent all this time, found a very interesting insight that you could act on, and the competition just kind of learned about it. Oh, really? Well, let us see if we can do that. Their results would be different. So, for instance, if your finding was that, okay, ATMs should be in this zip code, should be replenished 3 times a day, right? When you run your data through a similar problem statement, another competing bank, you may find out that you need to replenish it twice and not thrice. So it's not that the exact insight and the decision, business operation strategy that you came up with would be directly applicable to them, but now they know what to look for. And if they know what to look for, they can quickly go in and figure that out. What I'm talking about is decision analytics, and that is kind of the democratization of analytics, that every single decision in the organization should be complemented with analytic capability. So it's a bottom-up approach. You start at the lowest level. You don't start at the top. On the top down, you may see 20% revenue increase over 10 years. On the decision analytics approach, you may see hundreds of business units and managers and departmental operational metric that can yield 1% each. So you have 100% revenue or efficiency coming in versus 20%. That's top down, this is bottom up. So in order for this to be bottom up, you've got to be able to take the existing decisions and complement them, because you really don't want to change the way they do things. You have to kind of slowly evolve. It's an evolutionary way of doing things. And how do you do that? So this is the start. So the democratization means every single middle manager should adopt analytics in their functional areas. So first you have to find a problem statement that you're going to build a predictive model, and the model is going to give you some output, and based on that you will take decisions. So the simple way to do that is that every single middle manager today looks at some metric. They get some reports out of their data warehouse or their data mart. There are certain metrics that their bonus and their promotion and their performance is tied to, and they diligently go after making sure that that metric is achieved and is delivered. So all you have to do is build a simple predictive model that if it's a month-end metric, so towards the end of after the end of the month, you receive that metric, it's already too late. The month is gone. You missed it. So now what you do is you predict that metric on the 20th of the month. So if the prediction says that, oh, you're going to miss it by X%, right? Well, you would still have 10 days to do something about it. You can redeploy more resources. You can readjust your operational activity. You have some chance of success even with those 10 days. And a predictive model that an existing metric coming out of the data warehouse has all the relevant data for that metric in the data warehouse with the history in there already. So you really don't need to, you've cut down the time of collecting all this information from various places. The data warehouse already has it. All you need to do is take that metric, take the relevant data, run it through a data mining tool, the output comes out, it gives you a number, and based on that, you work backwards and try to figure out how can I improve it. Some advanced tools will let you do some what-if scenarios. So you say, okay, what if I deploy 5 more people? Is that going to help? What if I cut down this activity versus that activity? What if I rechannel my resources into this corner versus that corner? So there are some tools that can help you decide what to do if your metric is actually short. But savvy managers know it. If they have this information up front, they know what to do to make that number. But the key here kind of gets into how to use that analytics model output. And this statement kind of goes back to the opening of the presentation where the the data scientist kind of came up with, well, you know what? Well, let's get one of the pilots run. Well, that's not going to help, right? So who's going to decide? That has to be that manager, that operational manager. So the data scientist's job is kind of limited to predict and then hand over the results to them. And then they have to figure out what they're going to do with it. And that's the crux of the success or failure of that analytics activity. If they come up with some creative way of making some changes to their business activity and their operation, and they meet that number, they're a superstar. As one manager becomes a superstar using this, the next one becomes the same, the next one becomes the same, and the data warehousing team is already serving them with monthly reports on the same metric anyway. So there is really nothing that you're asking to be changed apart from deploying a data mining tool on top of your existing data warehousing environment. Now this is assuming your data warehousing environment has been done correctly, there's good ETL support behind it, it has hooks into the operational systems, it brings data out regularly, it cleanses it, and I mean like all of those good things that we've learned over the last 15, 18 years have to be in place in some shape or form for this thing to work. And that is why that information continuum that I showed you, the predictive analytics or the analytics piece that helps you with what you should be doing sits on top of what we have done before. If your middle layer of your data warehousing is not in good shape, it will be very difficult to go directly from your operational data all the way into your future strategies. So here's another example. When data warehousing came along, and now I'm really dating myself here, but 93, 94 timeframe, the initial reaction in the industry was that, okay, well, let's start building this behemoth data structure. Every single subject area needs to be loaded. It took 1 year, 2 year, 3 year, not a single report came out of it, and you were still building this thing that, okay, once it's done, only then you will get value out of it. And that approach didn't work. And along came Ralph Kimball with his data mart type of an approach. He said, no, we need to deliver quick results. We cannot take this long to build this thing. So, key element of data warehousing's success and its adoption, every single manager jumped on it. Nobody pushed back on it. No, I don't want it. I don't want this technology. Everybody said, yeah, I need it. So simplification, quick results, evangelize. Once they started to see the value that it can add to your business activity, everybody wanted that. And then, of course, there was data management. The good, neat, clean data was in there, something that they had always struggled to get from the operational systems. And then it presented a holistic view. Again, something that they never had before. So data warehousing introduced a couple of new things, but it simplified and sped up the deployment of this thing. And that is why every single organization these days has a data warehouse. So if we take the same lessons and apply them to analytics, we have to simplify it. So, okay, I'm going to predict this metric. That's it. It's a very simple message. Every manager understands it. Every manager gets it. Quick results. So you are using your existing data warehouse and you're deploying a data mining tool on top of it. Very little investment, very little training required. And then you evangelize, and overall it gives them a good way of embedding analytics into their day-to-day activities. And of course, most of the pieces are already there, so you gotta reuse it. So it is up to the data warehousing team to step up beyond reporting and dashboarding and move into offering these predictive analytics to their savvy users. Every data warehousing manager or team knows which department is the most pain because they're, oh, I need this. Well, okay, you gave me this, I want it drilled down by this, I want it segmented by this and that. You know who the savvy managers are in the business. They're always on your door knocking, asking for more. That's where you start. That's where you start to evangelize and kind of show them what predictive analytics can do for them, give them information beforehand so they can actually make use of it and do something about it. So you use data warehousing as a foundation. So you have a whole bunch of departmental data marts and some analytical applications already running. You've got a whole bunch of reports, dashboard, graphs, all of that. And everyone in the organization is kind of hooked into this thing, into this infrastructure. They are already part of it. Leverage this relationship, leverage this connectivity, leverage this deployment infrastructure model which is embedded in your organization already. All you are doing on the analytics side is that operational data sources are there and the organization is there. So the bottom piece here and the top piece doesn't change. Bottom piece, top piece, because you're going to be dealing with all the data and you want to help every single piece of the org chart to make use of analytics. And then you have your data warehouse. You may have to build some specialized marts because in the analytics space, some data aggregation that you may require is far more complicated than what you handle in your traditional star schema type of approach. So you may want to look into maybe separating those aggregations out, building them separately. Over time, you will learn how to do this. I mean, you can start with a traditional star schema, nothing wrong with that. And then you put data mining on top of it. And once you have data mining, that's where scoring and modeling comes in. So if you want to, for instance, if you're a bank, you want to score your customers on risk, right? So the data mining tool will predict your default probability, and that probability can be translated into a score, and that score, the bands of those score can be used to make decisions on what you want to do with those customers. So, and then you build your decision strategies as to, okay, if a customer does this, this, and this, and his probability is that, I'm gonna do this. So this is what a decision strategy is. You bring all of this together into a business rule. That's what it is. You have a handful of resources at your disposal. You've got hundreds of customers, thousands of customers, or if you were predicting something else, for instance, in the education sector, if you are predicting who's going to drop out of high school, if you're a school district and you want to predict who's going to drop out of high school, then the high school student counselors, you only have a handful of them, maybe 3 or 4. And you've got a wide variety of students available or potentially in a situation where they may drop off. So where do you deploy your resources? Your scoring and modeling and decision strategies is going to help you do that. That, okay, if the reasons for a dropout are potentially economic or academic, this counselor specializes in this, give me the ones with the highest probability of the dropout and let them work with it. Decision strategies is where you will get a lot of the innovative ideas. You may use it for a while, you may realize that it's not yielding benefit, you may have to change it. Same example in the education, that you may decide that, okay, you know what, everybody with 90% plus probability that they're going to drop out of high school, they're gone already. It's a lost cause. I'm going to try and save the ones who are between 75 and 89% probability of dropout. I'm going to try and save them because anybody above 90 is gone already. Who makes that decision? You don't know what's going to happen because predictive analytics was never available, so your existing business process doesn't know how to incorporate that into your decisioning strategy. So you've got to try a few things, run with it for a while. If it doesn't work, change it. So that brings constant change into your organizational execution. And then of course you need some audit control as to who's deciding who's changing the decisions, whether you're going to deploy this resource here or that. You need to record some of that information so you can go back and audit that. So this is pretty much everything I wanted to cover, and here's another kind of idea that you can start simple with your existing reports and metrics and build on top of it. And you can take a black box approach. You don't never need to explain to anyone what the data mining algorithm is. It doesn't matter. As long as the output can be explained, if you spend $100,000, you may get the Cadillac of algorithms. If you hire a couple of AI graduate level students, they can probably build you one for $5,000. So that, always treat that as a black box, that data mining algorithm. It's not important. You can tune it over time. Once you've proven the value, you can go back, get more money, and buy a more expensive algorithm. So, any questions here? There's a whole bunch of other content, but I don't want to kind of go deeper into the technical details or adoption details of this. The fundamental idea, as I said, is that you start with the data warehouse, you start with the existing metric, and you start with data mining. So we're going to leave a good 8 minutes or so for questions. Yes, please.
How is this going to evolve with big data and Hadoop and all these other technologies?
So the question is, how is this going to evolve with big data and Hadoop? So as far as the philosophy that I'm trying to explain here is concerned, it doesn't matter, because your data warehouse infrastructure will have to step up. Once you solve that problem, whether you need structured and unstructured data and all this petabytes of data that you may have access to through sensors and machines or whatever, you may have to build a Hadoop cluster which brings in all this data and then kind of aggregates it at an appropriate level and moves it into the data warehouse. Because eventually the present and the past doesn't go away. You still need to report on that data, new big data. You still need to report on it. You still need to factor it into your business activities. So I see that the philosophy of analytics is agnostic to it. The challenge is on the data warehousing infrastructure, how it brings in Hadoop and how it solves that complexity of big data. Yes?
So one thing you said at the very end sort of surprised me about the black boxing the model. What I'm thinking is if you say that the students who are 90% likely to drop out should just, be a lost cause in your example, or this department's going to get money instead of a different department, that people are very much going to be interested in that model and not let you get away with it's a black box, trust me.
Correct. So the question is that if you leave the data mining piece as a black box, then how do you get the business to trust its output? They're going to need to know and understand, why? Why is it saying that? This is what we call causation analysis. So decision tree in the data mining space is actually very good at it, and that's why I use that as an example in teaching. There is neural networks, there is naive Bayes, there are other techniques, but they are a little more difficult to explain and dig up the causation. Let me try to go back to the, in decision tree, the first variable that comes at the top, the data mining tool actually shows that to you visually in the tool. So it deploys the algorithm on the data and runs the data through it, and it gives you this visual in the visual form. What this is telling you is that age is the most important variable that is determining which way this is going to go. So when you run your student database through a data mining tool and you select the technique, because the data mining tools will give you which technique you want to use. If you pick decision tree, you're going to get a visual tree that looks like this. And the sample data that you run through it, maybe 1 million records, it'll show you the counts where they are falling. And you can see how many are falling out because of their age being this. And once, let's say 50,000 came through this node, and then 20,000 went here and 30,000 went here. Now you know these 30,000 here have this thing to be looked at. So the decision tree actually gives you the causation analysis, and you can actually go and and create what we call a treatment option that this population, if the idea was that everyone should be yes, so everyone should buy, right? Then you know that this population who was not a student and came down here, your marketing and sales folks need to understand why. Why didn't they buy? What can I do so that they do buy and I increase this percentage here? So when I said the black box, it didn't mean that you don't give them this level of detail. How you get to this is what you're hiding from them. Because there is deep mathematics that nobody understands outside of a few PhDs who are writing these algorithms. So leave it to them. Don't try to understand that or explain it to the business. Yes?
These models will definitely change over time. So what is the recommendation? And
So question is, these models will change over time. Absolutely. So for instance, if your sales strategy does change and they do something about it, that oh, we're losing way too many customers here, we need to do something about it, create another product or another incentive plan. So now all of a sudden your percentage here drops, so there is change in your business, which means you need to retrain your model, right? The approach that I'm suggesting is actually so easy to adopt and deploy that it doesn't take much to rerun the model, retrain the model. So you use data from January to June to train your data, train your model, and in July you put it to work. Then from July, August, September, you put it to work, and then you started collecting data from March to August, because now the change data is factoring in. So now you have a new data set of 6 months, you again run through it and see if the model performs or not. And this is something we call champion challenger. So the champion model is the one which is being deployed and is working, and the challenger model is the one you came up with. And you may try new things, you may add more data into it, the new variables into it, or something like that. Try it out and see how it works. So you sometimes have to run 2 of them, and you randomly deploy them on the incoming sales records. That okay, for these customers I'm going to use this model, for these customers I'm going to use this model, and you're going to figure out which one is working better. If the champion stays better, that means go back to the drawing board and keep working on your challenger model. If the challenger works better, then drop the champion and the challenger kind of comes up. So it becomes an ongoing activity within the data warehousing team to keep coming up with new models, keep trying new things out. Yes?
Yeah, in the ideal scenario, it becomes a cyclical process where once you've done your initial modeling, the whole concept behind it is you're giving the business something to react to. And they're going to make changes in their business process. Once they do, that is hopefully going to improve your results. And then you're going to retrain your model. And you go through this process iteratively over time. It's not a once and done kind of thing.
It's more of a comment that this cyclical process of you deploy a model, and that model actually enforces a business process change. Based on that, new data starts to come in and accumulate. So when you go back and retrain, you may get different results. And this is an ongoing cycle, and that is true for any predictive model. You have to constantly tune it and retune it, and that is why data scientist-based approach or a statistics-based approach is very expensive to do this on an ongoing basis. Data mining allows you to constantly retrain this as soon as new information is, new performance metric is available on a model, you promote it, and it becomes an ongoing cycle of innovation and constant improvement within that small business unit. Yes?
Are there any approaches or techniques to address false positives or noise in the model?
Certainly. So the question is, since this is a prediction, you can be wrong, right? What if the model is wrong and it's saying, well, this person is going to buy? You spend time trying to pursue that individual, but he doesn't actually buy. So that's what we call a false positive, because your prediction didn't work out. The way to address that is that you have to look at what is your current metric of that. So you are deploying your resources in the current non-analytic environment, and even in that environment, you are pursuing some leads which are not materializing. What is that rate currently? If that is, let's say, 20%, that okay, anybody we chase, about 20% do not materialize. So that means the benchmark that you're working against is 80%. If your model can do better than 80%, then it's a solid sale to your business. And the way to do that is you historically run that data through it. From a training set, you take 90% of the data to train, and you use 10% to actually test and see how well the model is performing. If it is performing at better than 80%, then your model is ready and you can hand it to the business. That is it. Thank you very much for your time.